Hi, you are welcome to this video. This is the C# Beginners series. Previously, we had talked about lists, we had talked about dictionary. All of these are collections. And in this video, we'll be looking at a few others, and we'll just to highlight that this actually exists. We don't really, I've not really had a need to use this that often, but it's just good to know about them. So basically, we'll just be looking at the Hashsets, the stacks, and the queues in C# and see how they work in case we ever need such data structures. So the Hashset is a collection that stores unique elements and does not keep duplicates. The major difference between a Hashset and a list is that in a list you can keep duplicate elements, but for a Hashset you cannot keep duplicate element. It will not take in duplicate elements. So for example, if you try to put in a duplicate element, it will not reflect that you put in duplicate elements. Let's go and look at an example of how a Hashset works in C#. Okay, so we'll just create a Hashset here. Let's create a Hashset, new Hashset, and this is how you declare it in C#. So we have a Hashset. So let's say we put in Hashset item 0, Hashset item 1, Hashset item 2. Now this is fine, and we could say we want to put in Hashset item, let's put 0 again. Let's put 0. Let's put this, let's say. So you see we have 0 appearing added 3 times. In fact, let me just put them together so it makes more sense. Let me add. So let's say we add item 1, like we added it, this about 5 times, and then we have item 2. Let me have this a couple of times too. So you see we have 0, 1, and 2. Now if we come here, and so let me just say console.writeLine, and we say the Hashset, the length, the count for it, the length for the items in this Hashset. What do we expect? We expect that we have 1, we have 3, and then we have 5 here, and then we have this 1, 2, 3, 4, 5. So we have 10. 2s are 10, 1s are 5. That is total of 18 items. So we expect that this will be 18, right? So let's run this and see what it comes up with. And we see it's just 3. How? We have 18 items here, but it just says there are 3 items. So actually what happens is that for a Hashset, it actually doesn't accept duplicates. So when you put in a duplicate, for example, when it adds this 0, it ignores this other 2 because it says 0 already exists, so it ignores it. 0 already exists, so it ignores it. When you come here 1, it adds this 1, but these subsequent ones, it ignores them because it already exists. When it tries adding, it says, oh, I already have 1, and it ignores those. And same thing with 2. So that is the Hashset. But let me change this back to a list, and let's see what happens now with a list. So let's see what the list will give us as its own count. You see, for the list, it gets all of them and says there are 18 items there. So for a list, it doesn't bother. If you want to add the same item 100 times, it's fine with it in a list. But for a Hashset, immediately it has an item that already exists. It doesn't add it subsequently anymore. So that's the biggest difference between a list and a Hashset. Also to note is that for the Hashset, you cannot index it. For example, you can't say Hashset at index, for example, index 0. This doesn't work with a Hashset. I will show us how we could access this in the next video. We'll be talking about how we could make access to the Hashset. But I just wanted you to know that at this point, you can't index the Hashset like you do index the lists or the arrays. That's just important to note. So this is a Hashset. So where do you use a Hashset? Where you want to guarantee that you have unique items. So for example, if I want to make sure that a user doesn't put in more than 1 0, or the number of numbers, for example, they don't duplicate it, for example, Hashset is a good data type to use there. So that is the Hashset. sets. Now, if we look at the next, which is the stack is a collection that follows the last in, first out principle. So when with a stack, what you see is that when the last item that came in, that you added, is the first item that must go out. No other item can go out except the last item that came in. So it said elements are inserted and removed from the same end, that is the top of the stack. So if I will show us what that means, if we have a stack, so let me just create a stack, and the way you create a stack is just like every other one. So this is how you create a stack. Now let's say you have in a stack, so imagine you have a plate of a place where you keep all your plates and you put them together on top each other. You know, if you are to pick a plate, the plate you will pick, you have access to, is the last plate you just placed. Whatever plate is at the top is actually the plate that you have access to pick. So that is a stack, because it is the last item that was put into that stack that is going to be accessible to pick out of it. So let's say we have a stack, and how you add to a stack is the push. So you push into a stack. So I push in 0 and I push in 1. Let me push into 2 so that we have, so I have 3 items here now. I've pushed in 0, 1 and 2. Now I can, what happens now is that when I come to this stack dot, so when you want to see when you want to get the last item, you use pop. So push is what you use to put in the item, pop is what you use to take out the item. So if I say the item that was put in last, I want you to pop that out. So that's what this does. If we run this, let me just put my breakpoint here and we run this. Let's see. You will see that what we have in pop is 2, and 2 was just the last item that was added to the stack. So you see, for the stack, pop will give us the last item that was put into it. So wherever you need this functionality where you want to be able to keep track of the last item, so where this is applicable is, you know, undo and redo. So, you know, you want to, when you have done subsequent items, when you say undo, you want it to do just the last item that it did, and then when you say undo again, you want to do the one that was after that. So it's in the order at which it was added to the stack, for example, that you want it to reverse back. So that is an example of where a stack is used. So that is basically how the stack works. Unlike the stack, we have the queue, which is first in, first out. And you imagine just a queue. Imagine you're on a queue maybe you are trying to get petrol, and the first person on the line, or the first person that gets to the line, is actually the first person that will get out of the line. That is the queue. But for the stack, as we saw previously, the first person to enter, or the first item inside, is not necessarily the first to go out. It is the last item that went in that will come out in a stack. But in a queue, it is the first item to go in that goes out of it. So for example, if we have here, so let me just create a queue, and just basically the same approach you use to create a queue, only that now you use a queue. But to add items, sorry, this should be var. To add item to a queue, basically all you just need to do is you enqueue. So we have the enqueue. What this does, so you want to add 1, you want to add 2, and you want to add 3, for example. Now, and this is how you add items to your queue. To remove from the queue, let me just, you use the dequeue. So we have the dequeue. So what this does is that it removes the first item that was put into this. So unlike for the stack, where when you pop, it removes this item and gives it to you. For a queue, when you dequeue, it removes the first item. And if we, let me put a breakpoint here, and let's run this again. So here you will see that for the pop, it carries 2, which was the last item that was added. Whereas for the queue, it gives us, when you check what is in the queue is the first item, which is 1, because that was the first item that was put into the queue. So this is the queue, and the queue also has some application. For example, in breadth-first search algorithm, it uses a queue as the basis for it, and that is where a queue, for example, could be used. So this also is another data structure we have in C#. Like the list, unlike the lists that you can access at any point from any of them, for the stack and the queue, and as we saw with the hash set also, you cannot just go and access the items by indexing. So for example, you can't come here and say this queue you want to check what is index 0, for example. This will not work. So if I show this doesn't work, this will definitely throw an error. It's already telling you that so let me stop the application so we can see clearly. So you see it's already trying to say cannot apply indexing on a queue. So queues and stacks, so for stack also the same thing. You can't say you want to check what is the first item by using an indexing. So those two will not work with queues, with stacks, and with the hash set. Very important to note. These are all collections like the list, the dictionary, the arrays, but these have unique features, and we've been able to look into that. Thank you. If you have any questions, please drop them in the comment section, and I'll see us in the next video.